Hello everyone. Today we're going to be talking about a popular sorting algorithm, Quicksort. Quicksort was originally developed by British computer scientist Tony Hoare in 1959 and was published in 1961. It is still a commonly used sorting algorithm, and when implemented well, it can be somewhat faster than merge sort and 2 to 3 times faster than heap sort. So let's move on to the presentation.
So we are going to begin our discussion on quicksort with a little guidance from this presentation. So what is quicksort? Quicksort is a sorting algorithm which uses the idea of divide and conquer. So basically it finds the element called pivot which divides the array into two halves in such a way that elements in the left half are smaller than the pivot and elements in the right half are greater than the pivot. Now the quicksort algorithm essentially follows these three steps. Find the pivot that divides the array into two halves, and then recursively quicksort the left half, and then perform quicksort on the right half. To better understand this algorithm, we're going to consider this example of an array which has 6 elements. And now we are going to use quicksort to arrange the elements in ascending order. So this is our unsorted array with the index and elements. This is our left pointer, which initially points to the first element of the array, and this is our right pointer, which is initially pointing to the last element of the array. And finally, we have the last pointer, the pivot, which is initially pointing to the first element. Now we are going to quicksort this array. Okay, so first we are going to remember this essential rule. All element to the right of the pivot are supposed to be greater than the pivot, and all element to the left of the pivot are supposed to be smaller than the pivot. As the pivot is pointing at the left element, we will start from the right and move towards left. So right now pivot equals 4 and the right pointer is so the sorry the so now the pivot is 5 and the right pointer is 4. So now we are going to check, is the pivot less than the right pointer, which is false in this case. So we are going to swap the pivot and the right pointer. There you go. Now we're going to check, is pivot less than the left element, which is again no. So we're going to swap the pivot to the right, and now we're going to follow the same procedure. But since the pivot is pointing to the right, we will start from the left and move towards right. Now we're going to check again, is pivot greater than the left element, which is yes. So we move left one position towards right. Okay, so there you go. We may move, and then we check, is pivot greater than left, which is again yes. So we move another position towards the right. Is pivot greater than left? And no, in this case, pivot is not greater than left. So we're going to swap pivot and left. And there you go, the swapping is done. And so now we move pivot to the left. Now the pivot is pointing at left. So we'll start from right and move towards left. Now we're going to check, is pivot less than right? Which is true in this case. So we move the pivot one position to the right. So we check, is pivot less than right? No. So we swap the pivot and right, and there you go, the swapping is done. Now we move the pivot to the right. Now we check, is pivot greater than left? In this case, yes. So we move left one position towards right, and we repeat the same process. But after repeating, now the left and right are pointing at the same element of the array. So at this time, 5 is the pivot and it is at the sorted position, and therefore all the elements left of the pivot are smaller and all the elements right of the pivot are greater. So the pivot has divided the array into two subarrays, the left subarray and the right subarray. Now we will perform quick sort on the left subarray because the right subarray is already sorted. Now similarly, we repeat the process and we check is pivot less than left, and in this case it's no. So we swap the pivot and right. There you go. So now we move the pivot to right and we repeat the same process and the array is sorted.